Okay, so today we are doing our last transformation, which is going to be our dilations. So up at the top, if you could just underline, dilation is making an object bigger or smaller. So just a note off to the side, this is going to be our only transformation that is not rigid motion. Oops. It's not rigid motion because my my shape is actually going to change in size. It's going to get bigger or get smaller depending on whether I'm blowing it up or shrinking it. So with dilations, my angles are still going to stay the same. My sides are going to be proportional. So these will be similar figures like we had done earlier this year. To write the rule for my dilation factor, my dilation rule will be D for my dilation. The first thing is going to be my scale factor. And then the second thing is going to be the center of my dilation. And so with my scale factor, when my scale factor is bigger than 1, that's going to be an enlargement. When my scale factor is smaller than 1, that'll be a reduction, or I'll be shrinking my object. So with the first one, writing my dilation rule, whenever I'm trying to figure out my scale factor is always equal to what I end with divided by what I start with. So with the first one that we have here, I'm starting with the triangle that the parallelogram that I just highlighted in yellow, and then I'm going to end with the parallelogram that I highlighted or that I just traced in red. And so what I'm ending with is going to be something that has a side length of 4. What I started with had a side length of 2. So my dilation factor will be 4 over 2, which is the same thing as 2. And then my center of my dilation is going to be point A. The center of my dilation, I can always draw a point from the center through the pre-image to the image. So for each point, as long as I can draw a line going through it, so from the pre-image to the image, from the start to the end, that's going to be my center of my dilation. So I drew a straight line from A through B to B prime, through C to C prime, and through D to D prime. With the second one that I have, again, I'm starting with this small black triangle, and then I'm going to move on to the big blue triangle. And so again, I'm starting with 4, and what I want to end with is this entire length here, which in this case is 12. So when I do my dilation factor is going to be 12, what I end with divided by what I start with, which is 4. So that's going to be 3. And then my center of dilation is x. Again, from x, I can draw a line through r to r prime and through t to t prime. These are where it starts getting a little tricky. So from these, I'm going to cross that off. I want to write a rule from the solid image to the dashed image. So the solid image is what I start with. The dashed image is what I end with. And so I'm going to start with the big triangle right here, and then I'm going to end with the red triangle that I just traced, the smaller one. So I'm actually making it smaller, so my scale factor needs to be less than 1. It needs to be a fraction. So what I am going to start with is going to be a side length of 5. What I end with is a side length of 3. So when I write my dilation factor, it should be a dilation of 3 over 5. Again, it's smaller than 1. And then I need to make sure, again, 3 is what I end with, 5 is what I started with. And then the center of my dilation is going to be x. Again, from x, I can draw a point through the point that I end with to get to the point that I started with. Just like that. It shrunk down closer to x in that case. Same thing with the next one that you have on the bottom right-hand side. I want to write a dilation rule from the solid to the dashed image. So solid image is what I start with, and then the dashed image is what I end with. And so, again, you should be able to see this. I'm starting with this trapezoid right there, and I'm ending with this trapezoid right here. So I'm starting with 16, and then I'm going to get to 9. So when I write my dilation factor, again, since it's getting smaller, I need to make sure that it's less than 1. The side length that I end with is 9. The side length that I started with was 16. And then if I look, point Z, I can draw a line that goes from Z through my image to my pre-image. So each one of those, I'm squeezing it in towards Z, and so my center of dilation is going to be Z. If you wanted to reduce the 9 over 16, that's fine. Those are both divisible by, no, you can't simplify that at all. So that would be my dilation rule, okay? Flip over to the back of your notes. On the back of the notes, it's pretty easy. When I'm applying a dilation rule, all I really have to do is figure out what the scale factor is and then multiply the x and the y by that scale factor. So in this one, I've got a dilation of 2. If it doesn't have a center of dilation, it'll always be around the origin. And so with each one of these points, I just want to take the ordered pair, and I want to multiply the x and the y by 2. So with point Z is the ordered pair -2, +1. G is 0, -2. And then P is 2, -1. And so with each one of these, all I want to do is my dilation factor is 2, so I can multiply the x and the y in each one of these by 2. Multiply every single x and y by 2. So when I do that, my Z prime is -4, +2. My G prime is 0, -4. And then my P prime is 4, -2. So when I graph that, I should be able to see -4, +2. 0, -4 goes 1 off the graph. And then 4, -2. And so again, there's my end. And from the origin, I can draw a straight line that goes through my pre-image to my image. With the next one, do the same thing. I want to use the dilation rule that has a scale factor of 0.5, and so I'm going to do the same thing. Same points, Z is -2, +1. G is 0, -2. And then P is 2, -1. So I want to multiply each one of these by 1/2. And so when I do that, I get my Z prime to be -1, 0.5. I get my G prime to be 0, -1. And I get my P prime to be 1, -0.5. So when I graph that, -1.5, it's there, 0, -1, and then 1, -0.5. And so I get this as my image. Again, it's shrinking because the scale factor is less than 1. And again, from the origin through the pre-image to the image, I can draw a straight line. Okay? And then the last one here, just using a scale factor. Remember that your image is what you end with, and your pre-image is what you start with. And then I can just apply my scale factor. So on the first problem on the bottom left-hand side, It says the height of a document on your computer screen is 20.4 centimeters. When you change the zoom from 100 to 25%, new image is a dilation of the previous image with a scale factor of 0.25. What's the height of the new image? And so again, what I'm ending with is what I want to find. So I'm going to make it x is equal to 0.25 times what I start with, which is a document that's 20.4 centimeters. Oops. So you can do 0.25 times 20.4 and get 5.1. So I get x is equal to 5.1. And again, knowing that my scale factor is 0.25, I should just kind of know that my new image should be smaller, so that should kind of make sense. Second one, it says the image of a button is 5 times the button's actual size and has a diameter of 6 centimeters. We want to find the diameter of the actual size, the pre-image of the button. So the image is 5 times the actual size and has a diameter of 6. And so I know that the image, so what I end with, is equal to 6. My scale factor is 5. And I want to find out what the pre-image is or what I started with. And so what I can do is I can go ahead and divide both sides by 5 and get x is equal to 1.2 centimeters. And that's it.